Hi Math 9 students. I just want to do the other part of 1.3. As you remember, we separated them out into two separate videos just to make sure that we take our time with these and are very careful. And as I'm sure you've noticed before, I make my fair share of mistakes as well. I've been off school as long as you have. So it's important that we write everything down and keep things well organized so that we can go back and track down our errors. Speaking of which, at the very end of the last video, I didn't read the question quite as well as I should have and made a minor error. So I'm just going to show you what that was. So it was for this question right here, where we were dealing with little blocks. And what I noticed after the fact, after I'd made the video, is that these aren't indeed 1 centimeter square blocks. It says right here, each cube has a length of 2 centimeters. So it's a minor error, mostly because I didn't read the question as thoroughly as I should have, but it's something that I should correct with you. So let's go to the first way we did it, where we found we were subtracting overlap here. So we had 5 cubes, and each cube had 6 sides per cube. So we came up with 30 sides total, which is correct. And then we had 4 sides overlap. So we subtracted those, and I got 22 centimeters squared, which would be fine if it was indeed the case where each side of the cube is 1 centimeter square, but it's not. So I'm just going to make another little quick drawing over here to correct my mistake. So this is 2 centimeters, and this is 2 centimeters. Ooh, not squared, just 2 centimeters. And let's use that to change our answer a little bit. So each cube has a face, or each side of the cube has a face that is 2 times 2 equals 4 centimeters squared. So we have to adapt this answer. Okay? So if we came up with 22, basically what we came up with was 22 sides, and then I just tacked the centimeter on the end, and I should have been centimeters squared anyway. Let's just fix this. So this is actually 22 cubes, or sides. And then we have to multiply that by 4 centimeters squared per side, which gives us 88 centimeters squared. So a small error, and all our math process was still correct, but because I didn't read carefully and find out that they were 2 centimeter by 2 centimeter cubes instead of 1 centimeter by 1 centimeter cubes, it made a big difference in our answer. And when we did the second part of the question, which was the same object, it was the same problem. So at the end here, this is really 22 sides total. And then for our surface area, it's actually 22 sides times 4 centimeters squared per side equals the same 88 centimeters squared. Okay, so maybe I'll take that out and I'll call that sides instead. And I'll do the same on the other one. So this isn't really surface area, this is sides. There's 22 sides. Okay, so let's move on to the 1.3 materials. And I think I might have showed you this slide on the last video. It's composite shapes. Now we've dealt with relatively simple shapes where there's been some overlap, but they've all been rectangular prisms, right? They've all either been cubes, which are, have square sides, or they have had rectangular sides, but it's all been 90-degree angles on every corner. But if we're doing composite shapes, they can come in all sorts of different mixes. For instance, if we look at the ice cream cone, the bottom part of that is a cone, and the top part of that looks to be about half of a sphere being like a ball. So that, that's very possible that someone could ask us to find the surface area of that, and we have formulas for the surface area of spheres and cones, so it's something we could do, maybe a little later. The building, all sorts of rectangles and parts that are overlapping, and at the top it looks like there's sort of a triangular area, so it's just an object composed of many other objects. The doghouse, the same thing. In the doghouse, we've got on the bottom part, if we just kind of separate the top part from the bottom part, on the bottom part we've got a rectangular prism, right? Everything's rectangles. And on the top part, we've got what's known as a triangular prism. So the front of the doghouse and the back of the doghouse are triangles, but the roof parts here are actually rectangles. So that's another composite object that we can make using triangles and rectangles. So the first question I want to do for this particular video is, it's straight from your workbook. Renee is using 3 pieces of foam to make her chair. Each piece of foam is a right rectangular prism, and we can see it. There's 1, 2, 3 pieces, and they're all exactly the same. The dimensions of each piece are 60 centimeters long, and then there's 20 centimeters here and 20 centimeters tall. So length 60, width 20, and height 20 as well. Here's the big question. Can Renee cover the chair with 2 meters square of fabric? We have to convert to meters first, okay? We are given dimensions in centimeters, but the fabric is in meters squared. So always convert first before you do any other math. It makes your life so much more simple. So what we're going to do first is we're going to do conversions. Okay, 60 centimeters. Okay, there's 100 centimeters in a meter, so I just really have to move the decimal 2 places, and I get left with 0.6 meters. So I've converted that to meters. The other sides are both 20 centimeters, so that's going to be 0.2 meters for both of those. So that should make our life a little easier, and if you want, you can just get rid of this and say 0.6 and 0.2. This one's also 0.2, 0.2, 0.2, 0.6. You know, write it as many times as you need to make sure that you remember 0.6, the lengths of each of these sides. Now we can get to work with actually figuring out how much surface area is there, and we have to be careful because there's an overlap here where the top of this piece hits the bottom of this piece. So we're going to have to subtract that at the end. Also, the back of this one is going to hit the front of the one behind it. So those are the 2 overlapping areas that we're going to have to remember those. So let's do the model where we figure out the total surface area if these 3 blocks were disconnected and they were all sitting side by side. How much surface area do we have for all of these? All right. So our total surface area. Okay, we've got 3 pieces of foam. I'll just call them 3 blocks. Okay, each block, okay, has measurements. So I'm just going to call this one block 1, this one block 2, and this one block 3. Okay? They're all the same shape and they're all the same size. So one block. Let's find out what one block is, and then we'll just multiply it by 3. So one block has a top and a bottom, and the measurement for the top and the bottom, all right, so let's just worry about this block out front here, the top and the bottom. So the top and the bottom are both the same. They are 0.6 meters long and they are 0.2 meters wide. So it's just length times width for area of a rectangle. So it's 0.6 times 0.2. Okay? 0.6 times 0.2, which will give us a total measurement of 0.12 meters squared. And if you want, by all means, use your calculator. Okay, so here's my calculator. Kind of a big calculator. I'm going to make it a little smaller. Okay, so if I just check that on my calculator, it's 0.6 times 0.2 equals 0.12. Okay, so we're happy with that measurement. The top and bottom. Okay, now what else have we got? We took care of the top and the bottom. Well, we've also got a front and a back, right? So this is front and back. Okay, and the front and back are actually the exact same because it's still 0.6 meters long. And this time we're going height, but the height's the same as the width, so it's still 0.2. So it's 0.6 times 0.2 equals 0.12 meters squared. All right. Now we've got the sides, right? So I'll just put the right side, left side. These are actually squares, right? Because the width of it and the height of it are the same. So the width and the height are going to be 0.2. So it's really just 0.2 squared, okay? Which is going to equal 0.04 meters squared. Okay, so we're using this to figure out what one block would be. And one thing we have to keep in mind here, because it's very important as I extend the page, is I only figured out one of these, okay? So I figured out the top, but we have to do it times 2 because it's top and bottom, right? So I'll just keep this as one block. Top, bottom equals 0.12 times 2, because we've got a top and a bottom, right? So that's going to be 0.24 meters squared. Okay, this is really the same as what we're doing up here. I'm just finishing it. So the front and the back, it's going to be the same thing, 0.24 meters squared. And then the right side and the left side, right side and left side, is going to be 2 of these, right? So 0.04 times 2 of those is going to give us 0.08. So for one block, okay, our surface area for one of these blocks is going to be equal to 0.24 plus 0.24 plus 0.08 meters squared, okay? So 0.24 plus 0.24 is 0.48, okay? 0.48 plus 0.08 is going to be 0.56 meters squared. Why not? Let's just double check the calculator and make sure I didn't make any mistakes there, okay? So if I check with my calculator, we've got 0.24 plus 0.24 plus 0.08. And that equals 0.56. So, well, that's good. We got that so far. This is one block, and that's important. Okay. But how many blocks do we have? We've got 3. So I'm just going to I like separating out my work just so I know what my thought process was. So I did this, and then I did that, and now finally, so for 3 blocks, we've got 3 times 0.56 meters squared is going to give us, let's go to the calculator, 3 times 0.56 meters equals 1.68 meters squared. Don't forget the units. 1.68 meters squared. So if these were separated, okay, they were just 3 blocks that are separated, not joined anywhere, we would need 1.68 meters squared. Well, if you really think about it, the question only asks us, can Renee cover the chair with 2 meters square of fabric? Even without doing any more math, we can say yes, because it can't be any more than 1.68 meters squared. It's going to be less because of the sections that are joined together. So really we could say already, yes, she can cover the chair, but let's just finish the math anyway. So we discovered how much the surface area would be if these 3 blocks were separated, but now let's take into account that the top of this block here is meeting with the bottom of the one up here, and that the front of that block is meeting with the back of this front block. The back of this front block. Yeah, it sounds a little confusing, but hopefully you get what I mean. So we have to subtract 2 measures for each of those sides because it's the 2 sections coming together. And we've already counted this section, and we've already counted this section, so when we put them together, we've got to get rid of both of them. So it's really important to remember that we've got to get rid of 2 of those. So we'll go back down here to where I left off with my math. Okay. So we're starting with 1.68, but then we got to get rid of the overlaps. So I'm going to put overlaps. And what are we overlapping? Okay. We are overlapping, okay, a top bottom and a front back, and they are all the same measurements. So we've got an overlap of 1 top bottom, which equals 0.24 meters squared. And we also have an overlap, okay, of a front back, which is also 0.24 meters squared. Okay. Now remember, when I did the calculation for this one, I already factored in that there were 2 of them, right? See, that's what this 2 is for. We already took into account that that's 2 of the sides. So I don't need to multiply the number by 2 again, because then I would have multiplied it by 4. Okay? So I can make a little note there if that makes that a little bit more obvious, is that this is 2 sides. Okay, and the same thing down here, that is also 2 sides. So our total overlap is 0.48 meters squared. I just added them together. Now we got to go to the last step. So our total surface area, okay, is going to be what we started with, which was 1.68 meters squared, which it would be if they were separated, but we got to get rid of all the overlapping. So that's 0.48 meters squared. Meters squared. And our final answer is 1.2 meters squared. So now we can answer with all certainty and say, if Renee, 2 E's I think, has 2 meters squared of fabric, it was fabric, comma, she can cover this chair. And we proved it, right? You can't just say at the beginning of the question, yeah, she's got enough. You have to be able to prove it, right? Okay, so that takes care of Renee's chair. Now let's do one that's maybe a bit more complicated, and that is a building that has another slightly smaller building attached to the front of it. So this one is a warehouse, the big one's a warehouse, and the front one is a little office space. Now we also notice that there's a door here and some windows and whatnot. We're not going to worry about those first. All we're going to worry about is the surface area of the building. Now, we're going into real life here, so let's think about it for a second. Do I really need to worry about the part that's touching the ground? No, I don't. It's touching the ground, so I'm never gonna, I'm not gonna have to paint it or anything like that. So I got to make sure that I got to take out the ground portion for both of these. And we've got all our measurements here. The only thing I'd say on this question is don't get confused between the 15 meter and the 10 meter. That's just for the door, so we got to ignore those. Okay, we got to ignore those. So let's determine the surface area for the building. I'm just going to call this building 1 and this building 2 to help keep it straight. So building 1, the big warehouse. What sides do we have here? We've got the top for sure, right? We're not going to do the bottom. We're just going to do the top because the bottom is the ground. So the top is going to be 60 meters times 30 meters. Okay, 60 and 30. So the top is going to be, if you do that on your calculator, you're going to get 1,800 meters squared. All right, that takes care of the top. Now, the front, let's do the sides first. The right side and the left side, those we both need. Okay, so we've got right side and the left side. Now, none of those are covered, so we need both of them, right? So I'm going to put 2, and each one of those is, this is 30. I can tell because it's 30 up here, which means it's 30 there as well. 30, and what's the height? 20. I can tell that from right here. So 30 by 20. So it's 2 times 30 meters times 20 meters. So 30 times 20 is 600 times 2 is 1,200 meters squared, or 1,200 if you prefer. So we've got the top of the building, we've got the right side and the left side. Now we've got to do the front and the back. I'm going to subtract this one later. So I'm actually just going to figure out the front and the back as if nothing was attached to it. So let's go with front and back. Okay, the front and back, so it's 60 meters long and it's 20 meters high. So the front and back is going to be 2 times 60 meters times 20 meters. Okay. So 60 times 20 is 1,200. Again, you can use your calculator in this class, that's fine. I just need to know that you can do it. The simple maths, the basic maths in your head when need be. But if it makes you more comfortable to double check everything with a calculator, by all means, go ahead and do that. So this is 1,200, but I got to multiply by 2. So that's 2,400 meters squared. At this point, we have to add up building 1 before we worry about subtracting any of the others. So I'm just going to add what we have so far. We have 1,800 plus 1,200, that's 3,000, plus 2,400, which will give us a grand total of 5,400 meters squared. But remember, that also includes this little section of the building here that's blocked off by the office. So let's just get rid of that overlap. Okay, office, back. So to get rid of that overlap, and I only have to do it once, right? I didn't consider both buildings together, so I don't need to subtract 2 of the back walls of the buildings because we haven't even looked at building 2 yet. So I'm doing this so I don't have to do a whole lot of subtraction later. So our overlap for that office back it's 20 meters by 10 meters, so the overlap is 20 meters times 10 meters equals 200 meters squared. So our total, and I'm just going to put 1 for building 1, is going to be 5,400 meters squared minus 200 meters squared equals 5,200 meters squared. That takes care of building 1. Well, obviously we've got to take care of building 2 as well. So let's go down a little bit further. I don't know, I had that in there from a prior recording, but we will get rid of that. Make sure I got nothing left before we talk about building 2. Okay, sorry, what did I have left here? 5,200 meters squared. Okay, so let's just draw a little separator here so we can deal with building 2. So this is building number 2, okay, which is the office. Now, what do we have in the office? We don't have to worry about the ground, we know that. So let's worry about the top. The top of the office is 20 meters by 20 meters. Now, when I read this question the first time, I think I mentioned that this 15 here is kind of confusing because it's close to the roof, but it's actually for the height of that door. So this building is 20 meters by 20 meters. See, there's the 20 for this section, and there's the 20 for across the top. So, gotta be careful when reading the questions. Let's do, excuse me, let's do the roof. Okay, so the roof of the building is 20 meters times 20 meters. Well, that's a nice perfect square, so that's going to be 400 meters squared. So we know we have that. We don't worry about the ground. We'll worry about, let's do left side and the right side, and they are both 20 by 10. So I'm going to put left side and right side. Okay, so that's 2 of them, right? Because I got the left and the right, and they are both 20 meters times 10 meters. So that's 200 meters squared, but I got to multiply that by 2 to get 400 meters squared. So that's good. And then what have I got? The front? I think I've got the front. Yep, I don't have to worry about the back. That's the reason I'm not worried about the back is because I'm never going to include it, so I don't need to subtract it later. So I'm just going to do the front of the office, and the front office, it looks like it is 20 meters by 10 meters. So I will put front equals 20 meters times 10 meters, and that is going to be 200 meters squared. So I think I've got that all taken care of. So for building 2, so total for building 2 is going to be the roof plus the right side and the left side plus the front of the building. So add that all together and you get 1,000 meters squared. I could put meters squared beside all of these. All right, so I've got 5,200 for building 1. I've got 1,000 for building 2. So for both buildings, we're looking at 5,200 meters squared plus the office space of 1,000 meters squared equals a grand total of 6,200 meters squared. As you can tell, that's only one part of the question. I've got another one below it. So hopefully, if we go slowly, carefully, keep track of all our sides, we get the right answer. Now we got to go a little further. Because now we got to actually do something. This is real life. So we've got to actually paint these buildings. And they've given us some information about the painter. So a contractor quotes $2.50 per meter squared. So for every meter squared of space, of surface area we have to paint on this building, and they're going to charge us $2.50. But there's a bunch of stuff we don't need to paint, and I'm just going to make sure that I keep track of it. I don't have to paint either roof. There's an office door they didn't tell us about. That's probably on the side here that is 2 meters squared. There's 3 loading doors that are 10 by 15. So here's one loading door. We can't see the others. Maybe they're on the side and back. And there's 4 office windows that are each 1 meter squared. We can see some of them here. So let's get busy with what we need to subtract. So total, and I'm just going to put 1, 2, because that's the total for both buildings. And we said that was 6,200 meters squared. We're going to need that because we're going to have to subtract all the other stuff from it. Now let's figure out what we need to remove. Okay, so let's remove roofs. So let's get rid of the roofs. The roof of the big one is 1,800 meters squared. The roof of the little one, let's see, was that 20 by 20? So that's 400 meters squared. Okay, we've got one office door that's 2 meters squared. Well, all right, there's 2 meters squared. And we've got 3 loading doors. So, sorry, this was roof, this was roof, this was office door. So I'll just put the O door. What are we at here? 3 loading doors. So I'm going to put L doors. Doing a little math for this one. Each loading door is 10 meters by 15, and we need 3 of them, right? So there's 3 times 10 meters times 15 meters is going to give us a grand total. Well, 10 times 15 is 150, times 3 is 450 meters squared. And then we got 4 windows, but I think those 4 windows, well, there's 4 of them, and they're all 1 meter squared, so that's just 4 meters squared total. So what do we need to remove? Let's get one number for what we need to remove so that we can just make a simple subtraction at the end. So we got to get rid of 1,800 for one roof. We need to get rid of 400 for the other roof. We need to get rid of, I'll use the bigger numbers first. We need to get rid of 450 for the overhead doors. We need to get rid of 2 for the office door and 4 for the windows. So how much do we have to get rid of in total? That's a 6, 5. 4 plus 4 plus 8 is 16. So 2,500 or 2,656 meters squared is what we need to get rid of. We're getting a little more space on this one, as usual. So that is important. All right. Now, so I'm going to separate this and I'm going to say how much needs to be painted, or total paintable area. We started with 6,200 meters squared, but that included the roofs and the window space and whatnot. So all this stuff that we have to get rid of equals 2,656 meters squared. All right, so let's just bring out our calculator for that one. 6,200 meters squared. Subtract 2,656 meters squared leaves us with 3,544 meters squared. So 3,544 meters squared of paintable area. We're not done the question yet. We needed this for something, and what we needed this for was to figure out how much it cost. All right, so it costs $2. Always put the dollar sign up front. That's an error that's kind of always driven me crazy in math, is don't put the dollar sign behind stuff. That's the way they do it some places in Europe, but in Canada and the US, it's dollar sign always up front. So it costs us $2.50 per meter squared. How many meters squared do we have? We have 3,544. So for each of those meters squared, we got to pay $2.50. So that's a multiplication question, right? So total cost equals 3,544 meters squared times $2.50 per meter squared. Once again, it's probably a good idea to go to the calculator. Okay, so we've got 3,544 times 2.5, which is $2.50, which gives us a grand total of course it went away, $8,860. So 8,000, comma there, $860.00. And it's always a good idea to put a final sentence in. It will cost $8,860.00 to paint the buildings. Okay, hopefully it's been made clear from me to you that you've got to take these questions step by step. You've got to go very slowly. I mean, just look at how much math it took us to get to the final answer. You know, that was only the last part of the question. We also had to do all of this math. So when so much math is involved, it's simply unacceptable to just write a final answer down or to skip half the steps. There's so much that can go wrong, and there's mistakes that I've made, and you will make mistakes as well. And it's easy to track where your mistake was if you've written down all your steps and you've gone in a very logical, sequential order through those steps. Particularly if you're handing in a question like this on a quiz or an exam, we can give lots of partial marks for, let's say you've got 98% of the work right and you just made one little adding or subtracting error. We can give you almost full marks for that. Whereas if you don't show us enough work, we don't know where you went wrong, we can't give you any feedback as to how to improve it, and we can't give you the marks because we just don't know where you went wrong. All we know is you got the wrong answer. So take these one step at a time. Draw out diagrams, pictures, anything that'll help you out along the way, and hopefully you have success with them. They're long questions. Okay, try not to get too frustrated. Just one thing at a time, and you'll get better at them. Just like anything in math, practice makes perfect, and I believe in you. So we'll see you in 1.4.